In our previous video, we dealt with the rules of sort, okay? And if you recall correctly, we said the rules of sort govern multiplication, where we say root AB is equals to root A multiplied by root B, and where root A over B is equals to root A divided by root B. Now, in this video, we'll be dealing with the conversion from single sort to basic form, right? So, what is single sort and what is basic form? Now, single sort involves numbers like root 162, root 54, or even let's say root 45. Now, the basic sorts for each of these can be written as 9 root 2, and the basic sort or basic form for root 54 is written as 3 root 6, and the basic form of root 45 is written as 3 root 5. Now, the question is, how do we move from the single sort expression to a simplified basic form? Now, to do that, we are going to consider the rules of sort, basically the one that involves multiplication. So, we know, according to the first law of sort, or let's say the multiplication law of sort, that root AB is equal to root A multiplied by root B. Therefore, we are going to look for two numbers such that root 162 will be, let's say, root A multiplied by root B. So 162 can be an expression of so many things. 162 can be 162 multiplied by 1. 162 can also be 81 divided by 2, or multiplied by 2 rather. 162 in itself can also be 54 multiplied by 3. 162 again can, let's say, be 81 over 2 multiplied by 4. And if we continue in this format, we will see that all we have is 1, 2, 3, such that we will not have any fraction here. So let's deal with 1, 2, 3. Now, the question now is, how do we convert from single sort to basic sort? Now, if we look at this form now, we can now say that root 162, according to the multiplication law of sort, is equals to root 162 multiplied by root 1. Likewise, root 162 in this case is equal to root 81 multiplied by root 2, and root 162 in this case is equal to root 54 multiplied by root 3. Now, we can see therefore that root 54 doesn't give us a definite number. We know that root 1, root 2, root 3, or root 1 is 1. However, root 2 and root 3 are sorts. And we have established in the first video that root 2 is something like 1.414, and it continues. Root 3 is equals to 1.732, and it continues. Now, root 162 is what we're looking for. Root 54 does not give us a definite number. However, root 81 does. So therefore, we'll be going with the second one. So we can say that root 162 is equal to root 81 multiplied by root 2. Therefore, root 81 is equals to what? 9 multiplied by root 2. And this will give us 9 root 2. Root 162 is equal to 9 divided by root 2, just as we have here. Now, to sum up this up is that if we have a rational number under the square root sign, that means we have 162 under the square root sign, and it contains a factor which is a square of a number. Okay, now the factor that it contains here is 81, which is a square of 9. The sort can be reduced to a simpler form, to 9, okay, multiplied by root 2. Let's take the second example, root 54. Now, root 54 can be expressed in many ways. Let's begin with saying that 54 is equal to what? 54 times 1. 54 can also be what? 27 times 2. 54 can also be 18 times 3. And I think we're going to root 6. Therefore, 54 can also be what? 27 over 2 times 4. 54 in terms of 5 is 54 over 5 times 5. And for the 6 multiples of 6, now you can say that this is 9 multiplied by 6. Now we just take a quick look at this. 54, can we find the square root? Is there a definite answer or a definite square root of 54? No. Is there a definite square root of 27? No. Is there a definite square root of 18? No. And for 27 over 2? No. For 54 over 5? No. But for 9, there is a definite square root. So we are going to be going with this. So we are saying that root 54 will be equals to root 9 multiplied by root 6, because we are applying the multiplication rule of sorts that says 54, or let's say root AB rather, is equals to root A multiplied by root B. Therefore, this is now equals to root 9 is 3 and root 6 remains root 6. So root 54 in its sense will be written as 3 root 6. Now, we have a rational number 54 is under the square root sign, and it contains a factor which is a square of a number 9. 9 is the square root of 9 is the square of 3. Now this sort can be reduced to a number of 54, root 54 to be equals to 3 root 6. Now let's take another example, and in this case we'll be considering root 45. So 45 can be 45 times 1. 45 again can also be 45 over 2 times 2. Okay. And 45 in itself again in terms of 3 is 15 times 3. 45 in terms of 4 is 45 over 4 times 4, and 45 in terms of 5 as multiples of 5 will give me 9 times 5. So which are we going to pick? 9 times 5, because there's no definite square root of 45, there's no definite square root of 45 over 2, there's no definite square root of 15, and there's no definite square root of 45 over 4. However, there is a definite square root of 9. So we therefore say that root 45 is equals to root 9 multiplied by root 5, because 45 is equals to 9 times 5. Therefore, root 9 is equals to 3, and root 5 remains the same. Therefore, we can say root 45 is equals to 3 root 5. So let's write out the principle. We have a rational number. When we have a rational number in which the factor, it contains a factor that has a square of a number multiplied by, let's say, another number itself. So when we have this format, this can be reduced. Now if you look at this now, the rational number here is 45. It contains a square of a number 9, which is 3 squared multiplied by a number 5. In the same vein, we have a rational number 54. It contains the square of a number 9 and another number 6. And in the same vein, 162 is a rational number, contains the square of a number 81 multiplied by another number 2. Let's take 2 more examples on how to convert from single surd to basic form. Number 3. Now we have root 98. Okay, you can pause the video right now and try to do this on your own. When we have root 98 now, we write the forms of which 98 can be written out as 98 is equals to 98 times 1. 98 in itself is also 49 times 2. 98 is also, in terms of 3, 98 over 3 times 3. And in terms of 4 is 49 over 2 times 4. Now, if we take a look at this now, 98, there's no definite square root of 98. Is there a definite square root of 49? Yes. Okay. Is there a definite square root of 98 over 3? No, there's no definite square root of 49 over 2 neither. So therefore, we have a rational number 98. We have the square of a number 49, which is 7 square, and another number which is 2. So we can say that 98 is equal to the square root of 49 multiplied by the square root of 2. Okay, so to make this rule more profitable, we can add the square root of rational number is equals to the square root of a square of a number multiplied by the square root of the number. So to continue further, that means we are applying the law of our surds, where we say root AB is equal to root A multiplied by root B. So to finalize on this now, we say that root 49 is 7 and root 2 is 2. So therefore we can say that our root 98 is equals to 7 root 2. Okay, yeah, 7 root 2. So let's take one last example as we clarify this. That's this is question 3, no, question 4, and this will be question 5. So let's take a look at root 75. Root 75. Now 75 is equals to 75 times 1. Is there a definite square root of 75? No. 75 is equal to 75 over 2 times 2. And likewise, there's no definite square root of this. 75 is also equals to 25 times 3. And there is definite square root of this, so stop here. Okay, therefore in that sense, root 75 is equals to root 25 multiplied by root 3. So root 75 is equals to root 25 is 5, and root 3 remains the same. So root 75 is equals to 5 root 3. Now we have seen how to convert from single surd to basic form, single surd to basic form, and single surd to basic form. We can also see here single surd to basic form. Now the question is, how do we now go backwards from basic form to single surd? And that is what we'll be dealing with in the next video.